Hello everyone, my name's Mrs Jennison and I'm an Associate Director for Outwood Grange Academy's Trust. Welcome to today's lesson. Today we will be looking at the fire triangle. So before we start, it would be really useful if you could turn the notifications off on your devices. This way you can take part in the lesson and really focus your attention. It would also be really useful if you had a piece of paper and a pen to hand so that you could take part in the activities throughout the video. This lesson is a part of our Saving Planet Earth topic. Last lesson we looked at the structure of the Earth and the components of the atmosphere. Today's lesson we will be looking at what fuels need to burn. Our challenge is to be able to describe the conditions needed for fire. Our aspire is to be able to explain how manipulating these conditions will affect combustion. So before we start, I'd like you to name the main gases in the atmosphere and give their percentages. So you should have that nitrogen is 79% of the atmosphere, oxygen is 21% of the atmosphere, argon is 0.9% of the atmosphere, and that's the main 99.9% of the atmosphere. The remaining gases in the atmosphere are as trace, and they are carbon dioxide and water vapour. Now, burning requires air. And that's why I asked you to remember those percentages first. Burning is a useful chemical reaction, and that reaction is called combustion. And it's used by us for many different things. Heating our homes. We may use combustion in several different ways to heat our homes, either directly by something such as a log burner or a gas fire, or indirectly by using our boiler to heat water, which is then pumped into our radiators. We also use combustion when cooking food frequently, although not always, because sometimes we use electrical ovens nowadays. But if you have a gas oven or when you barbecue, you will be using combustion to cook your food. Many car engines, specifically petrol, diesel and biodiesel car engines, rely on combustion. They use that reaction to drive the engine, which will provide the thrust to push the car forwards. We can use combustion when generating electricity, be it by our more traditional power stations like coal, or some of our more modern biofuel power stations, like is seen on screen. A few less obvious uses of combustion: when we are in labs in school, we use combustion when we are using Bunsen burners, and rockets also use combustion to drive them. But what is required for combustion? Well, there are three things that are required for that reaction: heat, oxygen, and a fuel. Now, those three components can be placed together to make something called the fire triangle. This is the fire triangle. For any fire to burn, those three components are required. You must have heat, fuel, and oxygen. If you take any one of those components away, the fire will extinguish and it will no longer burn. Now, combustion is the name of that reaction that is occurring while the fire is burning. It can be summarised by a word equation. Fuel plus oxygen forms carbon dioxide plus water. Now I'd like you to have a go at answering these 3 questions. Give 2 examples of our use of combustion, give the 3 components of the fire triangle, and write a general word equation for combustion. So 2 examples of our use of combustion are cooking food, heating homes. You could have listed any of the examples we had in the previous slides. The 3 components of the fire triangle are fuel, oxygen and heat. And the general word equation for combustion is fuel plus oxygen forms carbon dioxide and water. Now let's start to look at the fire triangle in a little bit more detail. The first aspect we are going to look at is heat. Now a source of heat is required in order for ignition to occur, so actually to start the fire going. And different materials will have different flash points, and the flash point is the lowest temperature at which they will ignite. So heat starts the fire burning, and we know this because we can see times where fuels self-ignite due to their temperature increasing above that flash point. Fuel. A fire cannot begin if there is no material to burn. Homes and businesses are full of flammable materials like paper, oil, wood and fabrics, and any one of those can serve as a fuel for a fire. So when we are talking about fuels, we don't necessarily just mean the generic fuels, we mean any substance which can burn. And a fuel is a store of chemical potential energy. Now, there are many examples of common fuels, and we will look at some in this topic. Wood is a fuel, as is coal, oil, natural gas such as methane and ethanol. All of these are commonly used fuels in science, but like I said on the previous slide, a fuel is a substance that can burn and provide that energy for the reaction. Oxygen is needed to react with the fuel during combustion. Now, the Earth's atmosphere does consist of 21% oxygen. So in our atmosphere, there is always plenty of oxygen available to trigger a fire as long as the other 2 components, heat and fuel, are present. Now, a few facts for us to remember. Normal air contains 21% oxygen. Your fuel itself may also contain some oxygen. Now, there are many naturally occurring heat sources, including the sun, hot surfaces, sparks, friction, and electrical energy. So they are, even in your home, there is a lot of heat sources available that could ignite a fire. And fuel sources can be solid, liquid, or gas. They are not dependent on any particular state. Some solid fuels are quite difficult to transport, as are gases, which is why a lot of the fuels we use in our engines are liquids. But in chemical terms, fuel sources can be any state of matter. So I'm just going to give you a little bit of time to summarise what we've just gone through. So what is the role of each of those components of the fire triangle? So the roles are, the heat is required to ignite the fuel. The fuel is a store of chemical energy which reacts with oxygen during combustion. Oxygen is located in the air and reacts with the fuel. So let's test our knowledge so far with a quick quiz. This component is 21% of the air around us. Is it A, fuel, B, oxygen, C, heat, or D, all of the above? B, oxygen. This is a source of chemical potential energy and reacts with oxygen during combustion. Is it A, fuel, B, oxygen, C, heat, or D, all of the above? And the answer is A, fuel. Components which are needed for fire to occur. Is it A, fuel, B, oxygen, C, heat, or D, all of the above? And the answer is D, all of the above. The diagrams show two Bunsen burners. One burner has the air hole closed and the other has the air hole open. They'd like you to explain why opening the air hole of a Bunsen burner makes the flame hotter. I'd like you to think about the fire triangle in that question. What is the fire getting more of if you open that air hole? Then for question B, natural gas is methane, CH4, and it's burned in a Bunsen burner. So methane is acting as your fuel. We'd like you to complete the word equation for the chemical reaction in the clear blue flame. So now it's time to check your answer. So, opening the air hole provides that fire with more air or oxygen. Now, natural gas methane is our fuel in this reaction, so the word equation would be methane plus oxygen forms carbon dioxide and water. Now, I'm just going to play a little video after this that introduces you to some of the things we will be looking at in our next few lessons.
Hi, Mr. Wizard, I'm here.
Okay, hi, Christina.
Why did you tell me to put my hair back?
Well, today you and I are going to do some experiments that involve fire. And whenever you deal with fire, you have to be extremely careful. So I just wanted your hair out of the way.
Okay,
And
and
I
my
see,
sleeves are
yeah, and your sleeves are all rolled up. And notice back there on the table, I have a fire extinguisher. You know how to use them.
Yeah, you pull the
Pull out the pin
Pin
and
and
squeeze, right? Okay, and out comes fog.
Yeah.
Okay. Then I have water in the sink and everything else, so we're well protected because we are going to investigate the fire triangle, which is right there. See it?
Why is it a triangle?
Well, look, there are three important parts. You see what they are?
Oh, oxygen, heat, and fuel.
And you have to have all three to have a fire.
Okay.
And if you want to put out the fire, all you have to do is take one of them away. That's what you and I are going to do. We're going to start little fires, and we're going to put them out by taking one of those three things away. But first, here's a piece of paper. Would you crumple it up and put it in that flask? Okay. Now I'd like you to light the paper and then we're going to put the top on like that. So go ahead. Okay. I'll take the match. Okay. Let it burn a little bit. You stand by, put the top on. Okay. A little more, a little more. Okay, put the top on. What happened?
The fire went out. Why?
Yeah, why? Well, remember I said you have to take away one of these things and the
And we
fire
took
would go
away
out.
the
What did we take away?
We took away the oxygen.
Right, because we smothered it. In other words, we prevented more oxygen from getting into the fire. Now, you know how firemen do the same sort of thing?
They take cloth or a blanket and put it around.
Well, they put it on, anytime they want to smother it, they can use also the fire extinguisher, because that cuts the supply of oxygen as well. And then if you catch on fire, you put a coat or a towel or a blanket, anything around you to shut off the supply of oxygen. Okay, you can put the oxygen back up again. Now I would like you to light the candle. I noticed, by the way, that you light the candle by stroking the match away from you, which is good. You can put it right down here.
Okay.
Here's a little piece of wire made into a coil. You take it. What I'd like you to do is slowly and carefully lower it right down over the flame.
The flame went out.
Why? Plenty of air can get through the,
yeah.
you know, because there's a lot of space there. Lots of fuel. What's the only thing that's left?
Heat.
Okay, take the heat away up there. You see, the copper absorbs heat very easily. So you took away the heat from the fire, and that's what put it out. Yeah.
It's like when we take water and to put out fires.
That's how firemen use water, right. Most people think they smother it, but they don't really. They put it out by taking away the heat. In fact, here. Would you take away the heat? That's what you do when you blow out the fire, too. You blow the heat away from the fire. Okay, you can put the heat back up. What do we got left?
Fuel.
Fuel. This time we're going to have a forest fire. Behind the chart there is a house. And here comes the forest.
Forest of matches.
Yeah, you put it right down there at the end, at the edge of the forest.
Okay.
And eventually you're going to light this tree right here, that match. And now what's going to happen?
It's going to spread to the other matches and start.
It's going
fire.
down here like this.
Yeah.
And what do we got? What do we have to do over here with the thing?
Take away the fuel.
Okay, how are we going to do that? Well, have you ever heard of a fire break?
Oh yeah, that's when there's a road or something to stop the fire from spreading.
Or firemen sometimes actually go in and chop down all the trees and have a bulldozer in order to make a fire break to keep away the fuel. Yeah. So you see where that white tape, I put that white tape,
yeah.
Take away those matches and make a fire break. Okay. By the way, I'm standing by here with my squirters. Okay. So now you light the first tree over there. There you go. Now you go. Okay.
Oh, it's spreading to each match.
Yes, going from one match to the other. And this is what happens with a real forest fire, too. The fire burns and it sort of explodes and catches the next tree on fire and the next tree on fire. And I'm standing by with a match, and in case it doesn't catch that tree on fire, the wind blew it over and away it went. That happens in a real fire, too. The wind can come along and blow the fire from one tree to the other. In fact, sometimes the forest fire gets so strong that it creates its own wind because all that hot air is going up and other air is coming through. Okay, it's coming down to here, and we'll see if Christina's fire break will protect the house. You think it will?
I think it will.
You think I would want to burn up the house?
No.
With it? No, I wouldn't. Okay. Almost.
Is it going to do it?
It is going to go. Reach over. Okay, how did we put the fire out?
Took away the fuel.
Take away the fuel. Let's also take away the heat by blowing. Are you ready?
Okay.
So there we took away the heat, but how did we put the fire out here? We took away the
fuel.
Okay, so put it back up here. Okay, how do you put out fires now?
Take away the oxygen, heat, and fuel.
Right, and now you know what happens when you investigate fire with the fire triangle.
Yeah.
Now that's everything from me this lesson, and I will see you soon.